Hello viewers on YouTube. In this video tutorial, we are going to consider the geometry series, which is sometimes read for short or written for short as GP. So let's begin with the general term of a GP. For any series to take the pattern of a GP, then the terms in that series must be gotten from this certain formula: u of n equals to a arc to the power of n minus 1. So this formula is what connects the terms of any series that is a geometric series. So it is the formula used to generate all the terms present in that series. Having known the general term of a geometric series, it is important for you to know how to use it effectively. A is the first term that is present in that series, and R is said to be the common ratio. Sometimes you might not be given the common ratio, and the question is, how do you want to find it if that series is given? Consider this geometric series: 1 plus 3 plus 9 plus 27. First and first, let's say it's an infinite, so it continues like that. You might be wondering, how do you want to know if that series is a geometric series? For it to be a geometric series, it must have a common ratio R. And to find it, common ratio is simply the ratio of the second term, u of 2, divided by the first term, u of 1. And the first term is the same thing as A. So you can express it as u of 2 divided by A. Now, not only that, this common ratio can also be gotten by dividing 9 by 3, which means we can also set that the common ratio is equal to the ratio of u of n plus 1 divided by u of n. Notice that 3 divided by 1 gives us the same result as 9 divided by 3, and continues like that. 27 divided by 9, so it gives us the same result. So therefore, this series is a geometric series. And to find its common ratio, just take any of them, the subsequent one, and divide it by the previous one, you have your answer. So that's how to easily find the common ratio of a geometric series given that series. Now, earlier we said that this general term can be used to generate all the terms that will be present in any geometric series. So now let's make use of it effectively. Let's use it to get some other terms that will be present in this series. Let's consider u of 5, the fifth term. That's when n is 5. And this is the first, second, third, fourth. The fifth is not given, but with the help of this one, we can find the value of the fifth term. So that will simply be equals to a arc to the power of 5 minus 1, which will become a arc to the power of 4. Now we have the value of a, which is the first term, which is 1 in this case. Likewise, the value of r. All we need to do now is to substitute. So the fifth term becomes 1 times 3 to the power of 4. 3 to the power of 4 is simply 81. So therefore, the fifth term of this series will be 81. And this is how to easily use the general term effectively to find the value of a certain number of terms in a particular geometric series. Now, sometimes you might have a word problem involving this topic. So the question is, how do you want to answer them? So to get the concept in essence, let's try to go over some examples, as that will be the best one to get started. Example number 1. The sixth term of a GP is 16, and the third term is 2. Find the first term and the common ratio. So let's begin by writing the general term of a GP. We said u of n is a arc to the power of n minus 1. Now they said the sixth term, which is u of 6, they said is equal to 6. They said is equal to 16. According to this statement, the sixth term is 16. Similarly, they said the third term, u of 3, is equal to 2. Now, since we said u of n is a out to the power of n minus 1, it means if u of 6 is not given, then to find it, that will be equals to a out to the power of 6 minus 1, which is the same thing as a out to the power of 5. That will be equation 1. Similarly, if u of 3 is not given, then to find it, we would have done u of 3 equals a out to the power of 3 minus 1, which is a out to the power of 2. That will be equation 2. However, instead of u of 3 and u of 6, let's replace with these given values respectively. So therefore, we are going to have 16 to be equals to a out to the power of 5. That's the equation 1. And we are going to have 2 equals a out to the power of 2. Equation 2. Now at this point, we can divide one equation by the other. So the question is, which are you dividing by which? Well, what I would recommend is that you should pay more attention to the power of r. The equation that has the power of r to be the highest should be the one that you will be dividing the equation that has the power of r to be lowest with. So which simply means that in this case, the best thing to do is to do equation 1 divided by equation 2, because it has the power of r to be the highest here. So therefore, 16 divided by 2 becomes a out to the power of 5 divided by a out to the power of 2. 16 divided by 2 reduces to 8. A cancels out, and r to the power of 5 divided by r to the power of 2 becomes r to the power of 3. Some of you might be wondering, why is it r to the power of 3? Well, we have actually used some of the laws of indices at this point. We know that r raised to the power of 5 divided by r raised to the power of 3 can be rewritten as r raised to the power of 5 divided by r raised to the power of 2. And some of the law of indices was that when the bases are the same, we can take one and subtract the power, which end up with r raised to the power of 5 minus 2, which becomes r raised to the power of 3. Now this is the equation we have left over. To find out, the best thing is to find the cube root of both sides. So taking the cube root of both sides, we have the cube root of 8 to be equals to the cube root of r cube. So the cube root cancels the cube, and we have r to be equals to 2, as the cube root of 8 is 2. So that is the common ratio of the GP. Now let's find the value of a. Since we said that you can use u of 6, you can use u of 3, whichever you want, they will both work best for you. You understand? So let's use u of 6. I've actually getting rid, but I believe you have it copied down. We said the u of 6 is 16 equals to a r to the power of 5. Now that we have r to be 2, this simply means that 16 will be equals to a times 2 to the power of 5. And simplifying forward, we have 16 to be equals to a times 2 to the power of 5 is 32. And dividing through by 32, we end up having a to be equals to 16 over 32. And this fraction reduces to 1 over 2. So that is the first term. And this is the common ratio. That is the solution to this example number 1. On to example number 2. Find the common ratio given that it is negative of a GP whose first term is 8 and whose fifth term is 1 over 2. So kindly ignore this. That was a typing error. Okay. So let's begin. So the goal is to find the common ratio. And keep in mind, we are given a condition that it must be a negative value. So minus v. We are given the first term a to be equals to 8. And we are given the fifth term u of 5 to be equals to 1 over 2. Since we said that the general term of a GP u of n is a r to the power of n minus 1. I didn't mean u of 5 is not given as half. Then to find it, we would have said u of 5 equals a r to the power of 5 minus 1, which is simply a r to the power of 4. But it was given as 1 over 2. So instead of u of 5, we can have 1 over 2 equals a arc to the power of 4. Let it be our equation 1. But fortunately, the first term is given as 8. So in equation 1, let's plug in a to be equals to 8. And this simply means equation 1 will become 1/2 equals 8 times arc to the power of 4. The 8 can be get rid of by dividing through by 8 in both sides. Okay, and eventually at the right hand side we have 1 over 2 divided by 8 to be equals to arc to the power of 4. Now since equal sign is connecting them, we can flip it without having any issue. And we have r raised to the power of 4 equals to 1/2 divided by 8. And right now, at the right hand side, we can have r raised to the power of 4 equals 1/2 times 1 over 8. As have you done or used the method of keep, change, and flip. So you keep this fraction, you change the sign to product, and you turn this 8 upside down, which becomes 1 over 8. And this is the same as 1 over 16. So now the goal is to get rid of or to find the value of r. Okay, so how can we isolate r? What do you think? Since as a power of 2 or as a power of 4, 16 can be written as r raised to the power of 4 equals 1 over 2 to the power of 4. And if we give 1 to the power of 4, if we give 1 a power of 4, the result won't change. Now at this point, this 4 can be taken outside. And then we have r raised to the power of 4 to be equals to 1/2 or to the power of 4. Now since the exponent is not the same at both sides, it means the base will also be the same for that statement to be equal. So therefore, r will be equals to 1/2. However, the condition for the common ratio is such that it has to be negative. So therefore, the common ratio is minus 1/2. So this is the solution to the common ratio. And that gives us the solution to example number 2. On to example number 3. Hopefully by now you should have been getting used to the process of solving problems involving GP. By the way, if you are yet to subscribe to my channel, feel free to subscribe. Also, if you are enjoying this video, kindly give it a thumbs up so YouTube can recommend it to many audience out there. So let's begin. If x plus 1, x plus 3, and x plus 8 are the first 3 terms of a GP, find Roman figure 1 the value of x, Roman figure 2 the common ratio. So since these terms are in GP, it means the first term a would be x plus 1. Whatever begin that 6 is the value of a. Similarly, we know that to get the common ratio, that will be u of 2 divided by a. However, u of 2 is the second term, x plus 1 or x plus 3 divided by x plus 1. So this is a common ratio. Now, the third term, which is given as x plus a. To find it, if it was not given, what we're going to do was u of 3 equals a arc to the power of 3 minus 1, which is a arc squared. However, it was given to be x plus 8. So instead of u of 3, let's replace with x plus 8. And then we have x plus 8 to be equals to a arc squared. But a is x plus 1. And r is x plus 3 over x plus 1. So let's replace all these values respectively as well. It means we now have a new equation in the form x plus 8 equals a, which is x plus 1. Let me put that within the parentheses and write it properly. Oops. X plus 1, again multiplied by r squared, which is x plus 3 divided by x plus 1 all squared. Perfect. Now let's distribute this square to the terms within the parentheses. And then we have x plus 8 to be equals to x plus 1 multiplied by x plus 3 all squared divided by x plus 1 all squared. Now this x plus 1 can reduce one of these x plus 1, and left over would be x plus 8 to be equals to x plus 3 all squared divided by x plus 1. Now at this point, we can cross multiply. So upon cross multiplying, we have a lot of space, x plus 8 to be multiplying x plus 1, and this is equal to x plus 3 squared. Now let's focus on the left hand side. Let's expand these two binomials. So x times x results in x squared, and x times 1 gives us x. 8 times x results in 8x, and 8 times 1 gives us 8 plus 8. Perfect. Equals x plus 3 all squared. Incredible. I hope you are following the steps. Okay. Now let's simplify this forward, as there are some terms that are hardable. Compressing this equation, we have x squared. 8x plus x gives us plus 9x plus 8 equals x plus 3 all squared. Now let our attention be paid to the right hand side. Now for the right hand side, we now have, since it's a binomial squared, let's split it. Then we have x plus 3, x plus 3. And upon expanding it, just like before, we have x times x to be x squared, x times 3 to be 3x. We also have 3 times x to be 3x. And finally, 3 times 3 becomes 9. So simplifying this forward likewise, we have x squared plus 6x plus 9. These are addable. 3x plus 3x results in 6x. So let's bring this all the way downward. Then we now have x squared plus 9x plus 8. Now at this point, the goal is to cancel out anything that are cancelable. So you notice that x squared can cancel out. Now let's try and just set this to be equal to 0 and see if we can push it forward. Or let's separate the constant term from the variable terms. I think that's just the best step to do. Now that we have 9x plus 8 to be equals to 6x plus 9. That the 6x comes all the way to the side, and this 8 should move to the side. And therefore, we have 9x minus 6x to be equals to 9 minus 8. Upon subtracting 6x from 9x, we have 3x equals to 9 minus 8 is 1. So finally, dividing through by 3, x becomes 1 over 3. And this is the value of x. And that gives us the solution to Roman figure 1. On to Roman figure 2, which we are required to find the common ratio. If you could remember, we set up a formula earlier that gives us what the common ratio would be. And that formula is what we will be considering using. So I've got rid of it, but I'm going to form it back. But hopefully you have it copied in your notes. We said the common ratio is u2 over u1. So that's x plus 1 by x plus 3 divided by x plus 1. We got x to be 1/3. So putting 1/3 as x and simplifying forward, we would be able to get the value of r. So 1/3 plus 3. So let's find the LCM. LCM can still be 3. So 1 plus 3 and 3 is 9. Then we have divided by the 1/3 plus 1, that's 4 over 3. Okay, so I've done the LCM as well. LCM is 3. 3 and 3, that's 1. 1 and 3, that's 3. It becomes 4 over 3. Perfect. Now, 1 plus 9 is 10. Divided by 4 over 3. And right now, we can use the concept of keep, change, and flip and have 10 over 3 times 3 over 4. So these 3 cancels out, and we have our common ratio r to becomes 10 over 4. So this fraction can be simplified to 5 over 2. So 2 in 10 is 5, and 2 in 4 is 2. That is the solution to the common ratio. So that's it. So example number 3. If you have any questions so far, feel free to drop it in the comment section below. Also, if you are enjoying the video, like I said, you can leave a perfect and incredible comments. Alright, on to example number 4. The first term of a GP is 4, and the sum of the first 3 terms is 7. Find the possible values of R. Room of figure 1. Then room of figure 2. Find the possible fifth terms of each GP. So feel free to pause the video and figure this question out yourself by just applying all the techniques and concepts we have discussed earlier. And after that, you can unpause it and see if you got it right. So let's begin. Let's say the first term of a GP is 4. That's the value of A. That's equals to 4. Okay. And the sum of the first 3 terms is 7. Keep in mind, for a series to take the pattern of a GP, then it must be in this form. U of n is equal to A, the first term, second term AR, third term AR squared, fourth term AR cubed. Then this continues like that all the way to AR to the power of n. All together. Perfect. Now, since we don't know the series, and we said the sum of the first 3 terms of this series is 7, let's take the first 3 terms of this series, which is meant to be this. But we don't know. They are just values, they are just expressions. So let's add them up and set them to be equal to 7, and then plug in the value of A and see what we're going to have. I get what I'm trying to do now. Okay, good. So let's begin. So the sum of the first 3 terms, that's A plus AR plus AR squared. So they said the result is 7. Now earlier we said A is 4. So therefore we have, upon substitution for A, we have 4 plus 4R plus 4R squared equals to 7. And at this point, we can just try and set this to be equal to a quadratic equation, as we can see that that will be the best thing to do in order to get the value of R, as we are having a trinomial already. So let's bring this to this side in order to have an equation that is equal to 0. So we have 4R squared plus 4R plus 4, when 7 is common, becomes minus 7 equals 0. And therefore we have 4R squared plus 4R plus 4 minus 7 is minus 3 equals 0. So now we have a quadratic equation. So let's solve for R. Let's factorize. What 2 numbers multiplies to minus 3 times 4, that's 12. And at the same time, add up to 4. What are the 2 numbers? Would it be 3 and 4 or 6 and 2? Let's confirm. Minus 6 and 2 can definitely work. But we need positive 4. It won't actually. Let's consider plus 6 and minus 2. These result in minus 12. And addition result in positive 4. I think this is the best one to use. Now, some of you might have a challenge on how I got that. So it's better I simplified it. So the goal is to take that product, 3 times 4, multiply the coefficient of the first term with the constant term, that last term. So whatever you got, take it out. That's minus 12. So first, ignore the sign. Find all the factors of 12. Okay, what are the factors of 12? We have 1, 2, 3, 4, and 1. We have 6 and 12 itself. Understand? So these are all the factors of 12. Now, you want to express these 6 numbers. You want to express them as a product of themselves, whereby that product will be at the end of the day result in 12. So let's take. So what you're going to be doing now, you take the first one, combine with the last one. 1 times 12. You see that it will give you that thing back. 1 times 12 gives us 12. Incredible. Take the next one, combine it with the next one again. 2 times 6 gives us 12 as well. 2 times 6 also gives us 12. Now take this one, which is the last one, 3 times 4. Also gives us 12. 3 times 4 also gives us 12. Okay? They're just like you are trying to test one. You understand? Now, you will now be testing each of these values. 1 and 12. Is it possible in any way whereby you will add 1 and 12 or subtract 1 and 12 and at the end of the day you will get 4? Impossible. This one is out of the box. Let's move to 2 and 6. Well, we know that it's 2 and 6 already. Let's leave it. So the reason why it is 2 and 6, now you will know. Let's go to 3 and 4. Is it possible in any way you will add 3 and 4 or subtract them that you will end up with 4? Consider that this is impossible. If you add 3 and 4, you have 7. If you subtract 3 and 4, you can either have 1 or minus 1, which is absolutely impossible. So this is also out of the box. So that is the reason why this works out. You understand? No matter what, once you do it this way, you will end up with 1 that will work out. You understand? So 2 cannot work out, it's only 1 that will work out. And to know that, this is the best thing to use. But as soon as you do it often, you will realize that you won't need to do this anymore before you get what will work best. So let's move on. So we are going to replace the middle term with 6 and 2. So now we have 4r squared, okay, minus 2r plus 6r minus 3 equals 0. Okay, and let's factor out 2 in a bracket of, okay, 2r to c, in the bracket of r minus 1. So let's factor out 3 here. This will be 2 plus 3 in the bracket of 2r minus 1 equals 0. You know, 2r times 2r gives you 4r squared. So I made a mistake while factorizing. So let's take the GCF. 2r plus 3 multiplied by 2r minus 1 equals 0. Now let's set each of them to be equal to 0. 2r plus 3 equals 0, or 2r minus 1 equals 0. So for solving for r, 2r equals to minus 3 here, or 2r equals to 1 here. And upon dividing through by 2, r becomes minus 3 over 2 here, or r becomes 1 over 2 here. So these are the two possible values of the common ratio. And that gives us the answer to my figure 1, the possible values of the common ratio. The possible values of the common ratio is minus 3 over 2 and 1/2. Perfect. Now let's say we should find, in my figure 2, let's say we should find the possible fifth terms of each GP. Just like, the GP that has minus 3 over 2 as its common ratio will definitely be different from the GP that has 1 over 2 as its common ratio. That's why that question is in this sense, that we should find the fifth terms of each GP, because the GP will be different because their common ratio is different. So we want to find the fifth term of each of them. To find them, here's what we're going to do. Don't forget, common ratio, first term is 4. So we said u of 5 will be equals to what? That will be ar to the power of 5 minus 1, which is ar to the power of 4. Perfect. So when r is minus 3 over 2, then the u of 5 for that series will be, and let's assume the value of a remain unchanged. For each of the series, the first term is 4. So that's 4 times negative 3 over 2 raised to the power of 4. Okay, that becomes 4 times negative 3 to the power of 4. Here we can distribute the 4 to the entire fraction. Minus 3 to the power of 4 is 81, divided by 2 to the power of 4 is 16. So 4 here 1, 4 here 4. Final answer is 81 over 16. Perfect. Sorry, I wrote 16. That's supposed to be 4. Okay, 81 divided by 4. And when r is 1/2, so we have the common, the fifth term, u of 5 will be, okay, let me just write it somewhere. Let's put it here. When r is 1/5, or 1/2, u of 5 is ar to the power of 4. That's 4 times 1/2 to the power of 4. That's 4 times 1 over 16. 4 here 4. That's 1 over 4. So that is the common ratio for each of the GP, and that gives us a solution to example number 4. So let's move all the way to example number 5. So this is example number 5, and I literally changed my mind. You understand? So this example number 5 will be an addition to your exercise. It wasn't the exercise I prepared right from start, but I changed my mind and turned it into an exercise. So this is the exercise I prepared right from start. Question number 6. So you are doing the both. Solve the two equations. Solve the two questions and share a solution with me via the comment section below for review. So this is question number 6, and this is question number 5. Thanks for watching. See you in the next video. Bye for now.